Good morning. Let's build a fabric. We left off with our devices onboarded into Apstra. So we've got our vQFX elements deployed and they are onboarded as managed devices. This full control is what we're looking for with this acknowledgement check on the right. Today we're going to start building the scaffolding for our blueprint. As you might recall from the earlier videos, a blueprint is simply an intent-built fabric in Apstra. So if you have a blueprint that's been deployed, you have a fabric that has been deployed. Right now, we do not have any blueprints. But we can't start creating the blueprint right away. We need to define some input criteria. And this is where we start to see the declarative nature of the Apstra product. Today, we're going to be defining our resource pools. We've already sorted out our managed devices. We're going to create some interface maps and some device profiles. Now we already have device profiles for vQFX. So really what we're going to be doing is building interface maps, which are going to map our logical devices, which is a group of ports. You can just think of it as the interfaces on the front of your switches. And this is an abstraction layer because this interface logical device could be applied to any device profile from any vendor. We're going to merge these together though, and this is what's going to tell Apstra what kind of switches and how we're going to be using them in our fabric. And then we'll build our blueprint. So let's get started. Start with an ASN pools. And we don't want to have to put all this stuff in manually, so we're going to define a range of resources that will allow us to just tell Apstra to go build stuff. So we'll do DC1. And we'll add a range. We'll use the reserve space, 65, 199. And then we're going to create one for each data center for each blueprint, DC2. And this will be 65, 200 through 65, 299. Great. Done. See those two? Done and done. Now let's do some IP pools. IP pools. You might have seen VNI pools there. We're going to actually define our own VNIs as we go along. I like to map my VNIs to specific VLANs. You can do this however you want. This is just the way I'm going to do it. Let's create a new IP pool. And we're going to have quite a few here. DC1, loopback. This will be the loopback interfaces for the overlay, 168.1.0/24. And create another one, DC2. Loopback 168.2.0/24 and another one, DC1 fabric. These will be our interface IPs, 10.1.0.0/16. This could be 24, whatever. I'm just following some instructions I already created. And DC2 fabric, again, interface IPs, 10.2.0.0/16. And we'll create a pool for links that go to external systems. Not to be confused with the host subnets. This would be for connections out to external routers, uplinks into your core, your WAN. We'll call this external links subnet 10.3.0.0/16. Why not go big? We're not going to be creating SuperNet interface IP addresses. They're all going to be transit nets. Apstra takes care of that. We're just giving it a big old bucket to pull that information out of. Now we're going to create logical devices and interface maps. Design, logical devices. So create logical device. PR-12x10-spine. Logical devices are assigned to roles. So in this case, we're creating a vQFX logical device for the role of spine, obviously, which is why we're giving it a spine. And then we'll have leafs that are generic, right? So the leaf connects to spine devices, it connects to generic devices. So this is going to be for the spine. We have 12 ports on the vQFX, 0 through 11, technically speaking. So we'll just drag this over here. Juniper 0 indexes, so it's 1 through 12 here, it's 0 through 11. When we actually do interfaces, like actual interfaces, that is reflected with a 0 index, so that's a good thing. We'll say this is a spine. Boop. actually, this is a spine, so it connects to leaves. That's an important distinction. Don't write spine here and then click spine down here. Spines don't connect to spines. Spines connect to leaves. So we click leaf and create a port group and click create. Boop. So now we have this device with these interfaces. We'll create two, do another one. This will be JNPR-12x10 leaf. And this, since it's a leaf, will connect to spines and generic devices. Generic is just anything that's not managed by the fabric. So this would be a host. And since this is an edge routed and bridge network, we have border leaves, right? So the spine wouldn't connect to a generic device. Spines only connect to leaves. Same process from here too. We'll just move this so that we've got our 12 ports, create a port group, and click create. Now we put in JNPR, hit apply. There we go. Perfect. Verify that. Now let's create our interface map, where we'll join these two things together. Now if I type in QFX here, QFX, I should have some results that reflect the hardware solutions that we sell. And we're going to just connect those to software solutions. And I have a couple vQFXs already here, but these I believe come with the product. I'm going to create new ones for what we're doing. All right, R-12-X10-spine. Logical device is JNP. Spine. And then the device profile is our vQFX. vQFX. This is where hardware compatibility comes into play. This device profile here is where you need to have vQFX already supported. This is where Apstra knows the ASICs and what's under the hood of the actual device. There we go. Select interfaces, click one, drag out to here. All right, we want to make sure we've got all of the ports selected down here, and then we can click create and say create another. JNPR-12x10-leaf. This is moving somewhat slow. So what we might do is take a quick jump into Eve once this process is done and verify that we're not hitting any type of resource starvation. If we are, we'll turn it down, give it memory, and then turn it back on. vQFX, select interfaces. One, we click and we drag over to 12 so that we get all of these, and click and drag. And then create. Let's just double check our work. JNPR, enter, spine, leaf. Got them both. Perfect. Now let's jump over here to Eve real quick. Click on nodes, and nodes will bring up a list of running nodes, and we're specifically going to look for the AOS server to see if we're crushing it. No, we're good. Must just be me. If you're only using 16 gig, this number might be higher. I think I covered this in the server video. I don't have specific guidance on how to run this virtually in Eve for memory, so make adjustments as you need. The rules kind of start to break down when you put things into a lab like this in terms of what resources you need. So really the guidance here is just best effort, right? All right, so now we're going to create some racks. Design racks. A rack is a logical representation of the types of hosts and connections that you have into your leafs, your access leafs, and your border leaf for that matter. You can use the same rack type for your entire data center. However, you're likely going to have a bit of variance, so it'll be up to you to determine exactly how many rack types you're going to need. If a data center has been deployed, maybe it's a hyperscaler, and every rack is the same, or most of the racks are the same, you'll just end up using the same rack type, just chunk over and over. I'll start with the border leaf. It's pretty straightforward because there's no generic systems connected to it. In Apstra, generic system refers to a host that is connected into the fabric and is participating in passing traffic through the fabric. An external router that goes towards your core or is used for DCI does not count as a generic system. So the configuration here pretty straightforward. We just do border rack. We'll call it this leaf, the name of the switch. We'll just call it switch 1. Right? Is that right? Switch, and then it'll by naming it switch, it'll just name it switch 1 and switch 2 over here. In fact, if we want to give it a little bit more of a full name, I can say like bleaf, and it'll do bleaf 1, bleaf 2. We have a single, actually logical device, so GNPR is getting kind of jumping the gun there. We need to assign the logical device to it, telling it that it is this logical device, this Juniper 12 by 10 that we already defined earlier. Links per spine, 1. We're using ESI lag. That's it. Done and done. Create. Now we're going to build a leaf, an access leaf rack. We're going to build 2. If we look at our design here, DC1 has a pair of multi-homed hosts and a single-homed host. For that to load, see, 2 multi-homed hosts and 1 single-homed host, and DC2 has a pair of multi-homed hosts. So what we'll do is we'll create a rack for a pair of multi-homed hosts. We'll clone it, and then we'll just add a single-homed host to it so that we don't have to redo all the work. So we'll call this one server rack. We'll just keep it generic. We'll change the name when we start copying stuff in this case. So, let's see here. We'll just call it leaf. The other one is bleaf. We can make the distinction, I'm sure. PR, leaf, ESI lag, done. And now we go over to generic systems, and we'll add in our CentOS hosts. So CentOS, this is going to be running LACP. And I'll come back up here. This is actually, I'll end up being a 2, but I'll do that at the end so you can see how this builds out. So just give it a name. And in this case, since it's multi-homed, I'll make that distinction. We'll do an underscore multi-homed, add a logical link. And this is an ESI lag link. The way that Apstra does ESI lag links is you will create a logical link, and it's abstracted in this workflow, but if you're actually in the blueprint, you'll walk through it. You create a new link. If you set up a lag and you give 2 links the same name, and you say, define them as an ESI lag, it will connect those together. So that name is important. Here, that's abstracted. It is dual homed. We are using LACP mode active. Now, if we scroll up, you'll see this. This is what we want to see. So since we have 2 hosts, now I'll change this generic system count number to 2. And look at that. We're done. So create. Oh, almost forgot. We need to use the 1 by 10 because these are 10 gig. So create. Oh, what have I done wrong here? Oh, required 2. Yeah, I'm sorry. It's 2 by 10. Boop. Create. It's 2 by 10 because I need 2 ports for the ESI lag. I'm not going to edit that out. See? We even make mistakes too. I'm going to clone this. Server rack copy. And I'll just code server rack with sh. And I'm going to keep everything in place here, except I'm going to also add a single homed system. Name, CentOS underscore single home, generic system count 1, logical device. It's only 1 link, so we just do the 1 by 10, add that logical link in. We'll say, let's see, switch 1 dash link 1. And single homed, pure leaf, no lag. Speed. We look up here, see what this looks like now, and we can see that in the diagram it is what we want. So great. Click the clone button to finish the process. Now we have our border rack, and we'll have these 2 server racks. One that we'll essentially use for DC2 and one that we'll use for DC1. And I can change these names if I want to, make it a little bit more prescriptive. DC1. Actually, this would be DC2, update. And I can edit this one and say DC1. It might be a little bit more intuitive. Give it a second. These will all update, and then we'll use these when we build our blueprint. I should say our template is next. Rack types. So let's build our template. Template's the last step. We're almost done. Template. And we're going to create a new template. This is the last bit of scaffolding. So we will call this JNPR EVPN. This isn't the blueprint. The blueprints will be named DC1 and DC2. This is just the template we're going to use to build that blueprint out. Rack-based, all this stuff stays pretty much the same. We are going to be using, make sure that this is set correctly. Scroll down and start by choosing our rack types. Border rack, we need one of those. And to add a rack, server rack. This will be DC1, so we'll do that server rack for DC1. And we want to show the links. Logical spine. This would be JNPR. This is the built, and we definitely want 2 spines, right? So this is really starting to look like a data center design. Right, so great. This is that template. Pair of spines, these leaves. If you're building this out for your data center, you're obviously going to have more racks. You'd see this all populate out. And again, these are all just staging. You can have this completely built before you push any config. And we're going to create another. So we'll click on this button, create, and EVPN. I'm going to call this JNPR EVPN DC2. How about that? Check all that. Rack type. We've got the border rack. We've got our server rack. There's our DC2. Optical device. JNPR. Spine device. Pair of spines. Done and done. Now, since I named that one DC2, we'll name this one DC1. Boop, boop, DC-1. Update. Cool. Let's create our blueprint. Blueprint. Create DC-1, which is what we'll select here. So we'll start by building DC1, show the links. Perfect. Great. And another one, DC-2. Show the links. Looks right. Great. We are not done. Once this is built, there's still quite a few inputs that we're going to need to add in. And in the interest of keeping this video somewhat short, we'll do that in the next one. Why wait? I just stopped the last video. Let's get into this one. I really want to get these blueprints done and deployed. We do need to assign the resources to these blueprints, and that includes the resource pools like the ASN, the IP addresses, as well as the managed vQFXs that are in our Eve lab. So we'll do this one DC at a time. And essentially what we're doing is we're walking through and we are finding wherever these exist and we're updating the information so that they go from red little splats to green little happy circles. We'll start with staged and ASN spines. And we will assign, since we're in DC1, we'll know pretty much what we need to check. So we'll click that, and when we do that, we'll see this change. And we'll just go through and wash, rinse, and repeat. ASNs for leafs, DC1, save, loop back. This is loop backs for the spines, so we've got our DC1 loop back. Loopbacks for the leaves, we'll use DC1 loopback. And then these links between spines and leaves, which are fabric links, we will use our DC1 fabric. Perfect. Manage interface maps. My goodness. We'll click on here. Spine. These are spines, so we pick that interface map. Edit all these. And these are all just going to be that border leaf. Border leaf, border leaf, border leaf. Update. We're not going to bother with these. Those don't matter. Now we assign our system IDs. We'll edit this. We click on this, we'll see these IP addresses. So we obviously, there's quite a few in here. There are 2 places where things can get pretty sideways if you don't do them right. This is one of them. because this is one of the few things that the system just has to assume that you're putting the right information in. The other is the cabling map, which if you ever have a problem when you deploy a blueprint for the first time, it's always the cable map. It always is. It doesn't, the system won't deploy a fabric that's broken. It's not Apstra making a typo. So spine 1, spine 2, it's what, 11 and 12? Great. So 11 for you, 12 for you. You'll note that these go directly into a deploy mode. That's fine. Just leave it like that. Border rack leaf 1. So 15 and 16 here. 15, 16, and then server rack leaf 1. And then we don't have anything for these generic systems because they're not managed by the fabric. And that's what, 13, 14, right? Great. 13, 14. Update assignments. I'm just going to wait for that. All right, that looks done. Go to uncommitted. Click commit. And, I did it. I forgot again. I just talked about it too. So funny. I guarantee if I go to this links and I edit this cable map that these are completely wrong. It builds these automatically. So if you haven't deployed your data center yet, you can create a cable map based on the output here and hand it to your facilities people, and they'll patch everything up and you're done. In the case where you've already got everything deployed and cabled up, you do need to come in here and edit this. So this blueprint's going to deploy. It is going to come up with all kinds of errors. And when it does, we're going to have to go in there and fix the cable map. But right now, let's go to DC2 and wash, rinse, and repeat the process to get this deployed as well. We'll edit this cable map, then we'll go back to DC1 and fix that one. All right, ASNs for spines. DC2, save. ASN for leaves. DC2, save. Loopback IPs. DC2. Oh. There we are, DCT loopback. Loopbacks for leaves. I remember coming in here once and like, oh my goodness, where'd it go? And I didn't even notice the fact that there was a second page. I thought I'd made a mistake. I do remember that there's a little arrow there if you don't see the resource pool that you created. And then our DC2 fabric. There we go. Device profiles. Edit. This would be our spine. Spine, done. And then I think there's a way to do all of these at the same time. Leaf, assign, done. Great. And our system IDs. Here this time, 21, 22. 2. Order racks. 25, 26, and then 23 and 24. Great. Now, do not commit yet. Go here, links, click this button, edit. Make sure this is all correct. Right now it is absolutely not. So I'm not going to make you sit through this, but I will do it now, and I'll probably just fast forward. These are likely going to overlap with IPs that I already, or links that I already have defined. So let's look at these. 0, this is 1, 2, 1 and 2. So we'll just make it 3 and 4 for both of these. And we'll do that on both sides. So this will be 3. Pay attention to this system ID here. We'll update these so they're more intuitive. This tells us which system things are going to. So we've got system 1. We're probably going to want to make the lower of the 2 numbers. So that'll be a 3 and a 3. And then system 2 can be 4 and 4. All right, let's update that and see if we got anything. If you have overlapping, like use the same interface twice, it'll throw an error. So in that case, it didn't. We'll commit. And if there's any problems, guaranteed it is the cable map. Go back to our blueprints and let's fix this, because this is going to be all kinds of messed up. links until we fix the cable map, because this is all broken. So again, I'll work on that, fast forward, and come back when it's done. 4, 4, and we'll make this one 0 because we're not using 0 yet, and it's single homed, so that'll work out fine. Update. Oh, what? Didn't type that in. Are you system 1? So you're a 3. Update. There we go. Commit. Pardon me. And commit. While that's running, let's see what's going on with DC2. BGP anomalies. Like I said. Now, this still might be baking in. Again, if there's a problem, almost certainly because I did the cable map wrong. So spine 2 to the server rack leaf 1, spine 2 to server rack leaf 2 is 2 and 0. That's not right. Server rack. So spine 2 to server rack leaf 2. Oh, wait. See, I even got that backwards. It's 2 and 2, and then 2 and 1. So spine 2 to server rack is 2 and 2, and then spine 1 is to the server rack is 2 and 1. Where are you? Spine 2 and 1. 2 and 2, 2 and 1. Okay, so there was one change. Right, done. Commit. Commit. Got a blueprint here. This looks like it's still deploying. See those anomalies coming down. So we'll give this a minute to bake in. Coming back in, what I saw here is this cabling anomaly went down to 0, and then everything else followed suit. So DC2's up and running, Fabric's good. Still seeing this in Fabric 1. Now there is something else that could be going on here. I just double checked the cable map and it looked okay. So let's go check our hosts because we are using vQFX, and it's possible that one of these devices came up in a line card mode. Now I discussed what to do if this happens in one of my previous videos, the one where we're deploying the vQFX. I'm wondering if that's what's happened here, because after double checking the cable map, my expectation is that everything should be up. We shouldn't see any cable anomalies. So let's do show BGP summary. I see that we're in a connect state for 2 of our links, which tells me that it's a little bit later. You're looking at the clock over my shoulder. What ended up happening is that I could not for the life of me get this node to connect. It was getting provisioned, but it was not sending packets over any of these links. And I ended up having to delete the node and redeploy it in Apstra, which is fairly quick. The workflow is that you go find the node, click the node, and get to the build, go to the assigned system IDs, essentially delete it here. This is spine 1, so you click that delete button. Then you go back to your devices, you pull the agent off, check it, and uninstall. And then go to your managed devices, change the mode here to be, oh, hang on here, admin state, to decom, and then delete it, and then re-onboard. The whole process, if you know it, takes about 5 minutes. I had never done it before, but it took me 10 maybe, and that took me over the course of an hour and a half because I did have to get into some meetings and come back to this. But once I redeployed everything into Eve, and this is an Eve problem, not an Apstra problem. It's just happened periodically where the links just don't work. You've got to delete the device and reinstall it, and then it works fine. And after that, it's not an issue. I don't know what's going on under the hood, but I've never had something fail, fix it, and then have it fail sometime in the future. It's just something to do with the way it gets deployed that first time. In any case, brought it back up, and I had to reboot it once after it was reprovisioned. I was having this anomalous BGP issue where it was just saying, sorry, it's just not working without any other information. I gave it a kick, bounced it, it's fine. Again, vQFX, if you don't see this type of behavior with physical QFX, once the lab is up and running, it is very, very stable. And that's where we're at right now. If we look at our blueprints, we have a deployed fabric. That wraps this up. The next video is going to deal with, I think, host deployments. Hang on, let me go check. Apstra, next one is adding hosts. Yes, so we'll add our hosts and do some service provisioning and build our DCI. I think that's probably 2 videos. Thanks for watching. Thanks for the patience. I say this every time, but hopefully now that this is in the rear view, the other videos will be a little bit shorter, so hopefully I can get them done a little bit faster. Thanks for toughing it out. Have a great day.